Hello everyone, today we'll be going through displacement time graphs for A-level physics. Alright, let's start off by defining displacement. So, displacement is a distance from the start point in a given direction. And because it's a vector, we have to specify that it has a given direction. Alright, let's take the first graph here. We have displacement on the y-axis and time on the x-axis. And we can see from this graph, it's just a horizontal line at 10 meters. What this means that its object is stationary. This is because it's staying at 10 meters away from the start point, which is at 0 meters, for 10 seconds. This means that the object isn't moving anywhere, and henceforth is stationary. Alright, we've got a second graph here. This one has a positive gradient. So, positive gradient means that we're moving from 0 meters to 10 meters away from the start point in 10 seconds. This means that we're moving with a constant velocity away from the start. So now we have a bigger, more complex displacement time graph. I split into 3 sections so I can explain easier what occurs in each section. So in section 1, we'll go from 0 meters to 20 meters in 10 seconds. This means that the object is moving away from the starting point until it reaches 20 meters. When it reaches 20 meters, it remains at that position for another 20 seconds, so it's stationary. And then now we have section 3, which goes from 20 meters to 0 meters in another 10 seconds. Sorry, it's not very clear here. So section 3 shows that the object is moving back from 20 meters back to the starting point. So it's moving at constant velocity back towards the starting point. So what does the gradient of a displacement time graph actually represent? So we know that the gradient of a graph is depicted as the change in y over the change in x. So in this case, we have displacement on the y-axis and time on the x-axis. So the change in y over change in x can be written as the change in displacement over the change in time. Now, because we have the change in displacement over change in time, we can also define the gradient as something else, and that is velocity. Hence, we have proved that the gradient of a displacement time graph is equal to the velocity. So now we're going to see how the steepness of the gradient affects the velocity. So we have two objects, object 1 and object 2, and they both take 10 seconds to travel their particular displacements. So object 2 goes 20 meters in 10 seconds, but object 1 goes 50 meters in 10 seconds. So we're going to see which one has a greater displacement. Alright, so object 1. We know that velocity is defined by the change in displacement over the change in time. So this displacement changes from 0 to 50 in 10 seconds. So the velocity is 50 over 10, which simplifies to 5 meters per second. And then we're going to see object 2. Object 2 has a displacement of 20 meters, and it does this in 10 seconds. So this velocity is equal to 2 meters per second. So here we can see that objects with a steeper velocity on the displacement time graph have a greater velocity than objects with a shallower gradient.